All right, welcome into my channel. I think we're live. Okay, happy Monday. How's everyone doing today? Right on time. Um, I have decided that I'm going to go ahead and do another one of these triangulation problems, finding the epicenter of an earthquake. What I'm going to do is I'm going to work. It's a different problem, similar method, but I want to try to solve it algebraically before I graph it this time. So see if I do a little bit better. Also, before I wrote this up here. That's the wrong intersection. It was 3. Silly me. I get in a hurry sometimes, but I noticed that. I just duplicated that center and made a mistake there. So little minor mistake, but it's worth correcting. Trying to polish my self up a little bit and get a little bit better, more concise about presenting these topics. I know that historically I've gotten off on tangents, and I go off on tangents and get distracted, and it is what it is. So it's really good to watch the video and reflect and make adjustments. So yeah, it's Monday, and I really was wanting to get into another subject. I wanted to get back into trig, honestly. I started this live stream the end of January, and I wanted to start it. I wanted to start it earlier. I wanted to start at the beginning of the year, but I don't know anything about technology, so they made me wait a while after I started my channel before I could actually go live, and I don't know. I just waited instead of I know I could have uploaded videos. I just didn't for some reason. I just waited. Anyway, a little apprehensive probably about getting in front of the camera, for good reason. You could see why. It's just because my personality. I could make a mistake. And if it's possible to make a mistake, I will find the mistake and I will make it. And it's just a reality. I'm used to it after all these years. It's not changed. Anyway, yeah. All right. So I asked chat for this problem, and let's see. It looks like I'm going to be starting out with the same circle. One of the circles is the same, and then the other 2 are different. So, all right. All right. So this one, none of them are the same. So we'll do this one. It gives us a center at, all right. So station 1, or we'll say station A. It gives us a center of -3, 0, and a distance equal to 5. Station B. We got a center at 3, 0. Okay, I didn't realize that was symmetrical, but then distance of 5. It looks like it's the same size, 5. And then we have station C. And for these triangulation problems, you have to have three circles because you have three vertices in a triangle. And that's what makes it a triangle. They use the centers of the circles to form a triangle. And radius of 2. The center is at 0,6. Sorry, I had to scroll. Zero comma 6, and it's a distance of 2. So what they're doing essentially is you've got all these cell towers and you've got all of these stations set up all across America in the infrastructure. And so whatever you're looking for, whether it's an epicenter, what they do is they have these sensors, and what they do is they locate they use three locations that are within, it doesn't even matter how close they are to the earthquake or where they think the earthquake is. So what they do is they measure a distance around that station. And they say, okay, well, here's the station center, here's the coordinates, here is the distance, and then they form circles around those cellular towers, and then they find out what data all three of those center datas, and then they map them on a grid system, and then where all three of those circles are touching is a location. It's a center, and that's how they zero in on whether they're trying to locate you on GPS using your cellular data. They'll be triangulating location according to the closest cell towers that you are pinging, your device is pinging to. But this is the same concept that they're doing. So remember that standard form of the equation. So you have standard form for circles. And we can use the standard form to write your equation based on the data given. Oh, what did I do? Y minus k. That's not right. It goes here. Y minus k squared equals r squared. This is x minus h. And your center is at h comma k from this form, and r is the radius. And we're going to use the distances for that one. So we can quickly write the equations here. We'll just put them underneath respectfully. And so we'll say x minus, and here we have h comma k. So this is going to be x minus 3. So it'll be x plus 3 squared. Because the form is negative and your value is negative, and two negatives make a positive. That's the reason why we write that way. And this one is y minus 0 squared equals r squared. And it's fine, we'll simplify it later. We can go ahead and get started. Okay. All right, so the second one. We've got center 3 comma 0, so it's going to be x minus 3 quantity squared plus y minus 0 quantity squared, because this room is hk, And then it's going to equal r squared. So it's 5 squared. And then this one right here, we get 0, 6. So it's going to be x minus 0 squared plus y minus 6 squared equals 2 squared. Okay. So what I want to do is I want to form a system of all three of these equations. So I'm going to simplify them and write them out. So I've got station A, B, and C. So this one, I'm going to go ahead and, well, we'll write the system, but we're going to have to simplify this quite a bit. So we have x plus 3 squared plus, we're just going to simplify this now and write y squared, and a equals 5 squared, which is 25. And then we've got to expand this, this binomial here, x plus 3 and x plus 3. So this polynomial here. So you have x squared. You're just systematically multiplying each term exactly one time. So it's x squared plus 3x plus 3x plus 9. And then that's x squared plus 6x plus 9. So I'm just going to rewrite this one and replace that there. So I have x squared plus 6x plus 9 plus y squared equal 25. And then if I wanted to subtract 9 from both sides, I'll have this equation, x squared plus 6x plus y squared, and that equals 25 minus 9, which is 16. All right, good. I'm thirsty today. I have a more quieter cup. I'm gonna get it out and remember. I don't remember until it's embarrassing and I'm making a loud noise on the camera. All right, so this looks a lot different, but this is actually A. So we'll label it, and then I've got some work to do. I'm going to simplify this one the same way. So expanding x minus 3 twice to save a little room. We'll just do it early. This is x squared minus 6x plus 9. And we have y squared. We have plus y squared. Just copy this one down. And that equals 25. So here's B. And then C, let's see if we can do that one real quick. So I just have to expand y minus 6. So we'll do that. Y minus 6 quantity squared. That turns out to be y squared minus 12y plus 36. And we've got plus x squared. And then that equals 2 squared, which is 4. So we've got to subtract 36 from both sides here. And that's going to be x squared plus y squared minus 12y. And that equals, let's see, 12y. Ew, negative 32. And this was C. Okay, this was C. All right, so I need to box these. Here's my equations. And let's see if we can solve these algebraically. We'll go and put them down here underneath A. So we've got A here. So we've got x squared plus y squared minus 12y equal negative 32. And we have this one, x squared minus 6x. Did we not subtract the 9 from both sides here yet? Minus 9. Let's go and do that now. Yeah, we did. 16. Duh. Hang on. Should have been the same. 16. Okay. Plus y squared equals 16. All right, so I need to be able to add these equations together and like eliminate two or three. Let's see. Is there a way if I add the first and third equation together, it's going to eliminate x. So I'm going to start by doing that. Okay, so let's do that. So I'm not really sure what to do. So we'll say x squared plus 6x plus y squared equals 16. And then we'll say x squared. Well, even if, all right, so, okay, x squared minus 6x plus y squared equals 16. Just add them. It's going to be 2x squared. And then that's 0. And then that's plus 2y squared equal 32. Okay, let's see. So that's going to give me 2x squared plus 2y squared equal 32. And then I'm going to take that third equation. See, we have x squared plus y squared minus 12y equal negative 32. And I think what I can do is multiply, multiply this second equation by 2, negative 2. See what happens. So that's going to give me, we'll just multiply everything by negative 2. It's going to be negative 2x squared minus 2y squared plus 24y, and that's going to equal 32 times negative 2 is positive 64. And then now I'm going to add it to that first equation. That's 2x squared plus 2y squared, and that equal 32. When I add these equations together, this is going to cancel, go 0. This is going to cancel, go 0. I'm going to have 24, and 24y equals and I got to figure out what 64 plus 32 is. So that's 96. So I end up with, this is nice, 24 I think 24 divides 96 4 times. 24 because it's real close to 25, and 4 quarters is $1. So that makes sense. Okay, 96 divided by 24 is 4. Cool. All right. As soon as you have your y coordinate, it's your second component of your ordered pair. Because when you're looking for a solution to the system, you're looking for an ordered pair, an x comma y. So I have the y component, and so now all I have to do is go and find whichever equation I want to use to solve for x. And looking to see if there's one that just has, that's easiest. Which one's easiest to use? I think I would use, well, I mean, they're all going to be kind of ugly. It's going to involve a quadratic of some sort, I think. So this got 2x terms, 2x terms. This one's got an x squared. Let's go ahead and plug it into the third one. This one here, I think will be the easiest. Actually, I think I can use even a derivative of, not, you know, what I mean a derivative. Like if I added those two equations together, I could use one of those as well. Okay. I think we're going to use the second one here. This one. Because then I only have one x term to simplify, even though it's negative. That might be the best thing to do. And we're going to work this because I'm running out of room. We'll just put it down here, I guess. So I have y equals 4, and then I'm going to use x squared. Get out of the way. Plus y squared minus 12y, and that equals negative 32. When y equals 4, I'm going to get x squared plus 4 squared minus 12 times 4 equal negative 32. And so I got x squared plus 16. 12 times 4 is 48 equal negative 32. 48 minus 16 is 32. It looks like 0. All right, because positive 16 minus 48 is a negative 32. And that equals negative 32. What happens is when you add 32 to both sides, you just get x squared equals 0. You take the square root of 0 and you get 0. Perfect. So it looks like the center is going to be at 0, 4. And then if we wanted to go ahead and graph this, I got to learn how to write smaller because my graph is going to be really tiny now. So I can skip this one over. I'm just going to erase that little chunk right there. I know that's not pretty, but I need a graph on here. And honestly, I would have probably got into identities before now. It's just, I've been doing this live stream now for a couple of months, and it would just be weird if I didn't draw a graph. So I tried to navigate away from just having graphs. I like drawing the pictures, and I like bringing the art into the math. So some might have to navigate away from the pictures for a little bit. I was trying to figure out how to incorporate the pictures into the identities. And so we'll just see how it goes. All right, so I've got these. I don't need the equation to graph them. I just need the center and the radiuses, but it's important to know how to solve these solutions algebraically. And so what we're going to do is we're just going to verify it graphically now. So looking at first station A center is at -3, 0. So we're going to say we want to kind of have the scale exact, so I'm going to use the ruler to do that. That's just so we can see that intersection clean. And we'll do the same thing here. Perfect. Perfect. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Get the graph set up. All right, good. Looks like we need one more up here. We don't need it, but let's, it would be, well, I was winging it there. All right. Okay. So we've got -3, 0. It's right here on the x-axis. Draw a nice big circle. And then we've got a distance of 5. So we're going out 1, 2, 3, 4, 5. Drawing a circle. 1, 2, 3, 4, 5. We're going to go up 1, 2, 3, 4, 5. And we're going to go down 1, 2, 3, 4, 5. And then we'll see if we can just pencil this in. Wait. Okay. Okay, we got that one. I always mess up the circle, dang it. All right, it really doesn't have to be perfect. Just remind myself that. And then the second one was at 3, 0. So we've got +3, 0 right here. And again, we're going up 5 here, 5 here, down 5, and out 5. 1, 2, 3, 4, 5. Just locating that radius all the way around. And it looks like we've got these identical circles. See if we can make them kind of somewhat look identical. Again, always that fourth quadrant gets me. That looks worse. One more time. All right, I'm trying way too hard here. Just slow down. All right. Okay. All right. And then we've got one more 0, 6. So we're up here. 0, 6 is up here on the y-axis. And it looks like we have a distance of 2, so it's a smaller circle. So we're going to go up 2. We're going to go over, let's see. That's a -1. Did I really do that? Hang on. Huh, I can't believe I did that. I put -1 out there. This is -1. I missed one. That's -2. Okay, not that it didn't mess up my calculations. I just had it labeled wrong. 4. It was not ticking and tying there. All right. So that would be 11 if I wanted it on there. I don't need it. All right. The fact that I'm finding my mistakes on the camera while I'm doing them is a modern miracle. Honestly, it's showing me that I am starting to get more comfortable with the camera. And so it's actually a good thing. A month ago, I wouldn't have caught that until I watched it later and looked in horror because I realized how imperfect I am. All right, so we've got 1, 2, down 1, 2. Just locating these radiuses. This one's going to be at -2. And then this one is going to be at +2. It's a much easier circle to draw when I only have a radius of 2. But at any rate, we should have this intersection. It looks like it should be, yeah, it's going to be right there on the x-axis, I believe. So we've got right there at 0,4. My graph was a little bit off, but it was close. We've got that intersection right there. So it looks like that's going to overlap just a little bit more. Anyway, a second chance at drawing out these circles and by hand is not easy, but it is good practice for me, and I enjoy doing it. Once upon a time, I considered myself an artist, and it's nice to be able to visually get that sketch back in there and practice the art while I'm doing the math. That's awesome. All right. Well, that pretty much solves the problem. We verified it graphically, that we did find the intersection of all 3 of these circles here. Yeah, so mission accomplished. And we can go ahead and stop there, 30 minutes in. And yeah, just go with it. I don't have any questions from students. Reminder, if you do have a question though, you're welcome to come and bring questions to me. I enjoy, working with students and doing the math as a group. And so right now it's kind of daunting because I'm doing math alone, but that's okay because it's important for me to do the math. And so I will show up, but hopefully I'll get some people that want to help me and do math with me. And maybe I could help them as well. It could be like a mutual thing. So I feel like that YouTube is a perfect platform for this, especially since we have all this free community space. So yeah, I encourage you to, if you are camera shy or if you are math shy, to be like me and come out of your shell. And yeah, it's better to be a human and make mistakes than an artificial intelligence any day of the week, I think. So it's no point in knowing everything without having that creative ingenuity and problem solving and engaging with people. So I hope that you enjoyed my stream. If you watched it, I greatly appreciate that. It helps knowing that I do have some viewership, and that does help me, believe it or not. Like, just from a psychological perspective, I don't think anybody really wants to feel like they're wasting their time. But if I'm just alone doing the math without the camera going, I feel like that, yeah, it's helping me, but it's not helping anyone else. So I thank you for allowing me to open up my camera and inviting myself into the world to, see and just get to engage with, I guess, my fellow humans that way, for lack of better words. But, anyways, again, I will stop rambling now. And I just want to say, I hope you have an amazing rest of your day. And yeah, if you want to come do some math with me, I will be here in same place, same time. Uh, uh, and so I look forward to seeing you again. And so I will sign off and I will say bye for now, and I will see you next time.